Good morning. Good morning. Week 9. Amazing. We only have 2 more weeks of classes. That's essentially 4 more classes, 4 more lectures starting today. Well, no, it's 5 more starting today. Well, you know what? Actually, well, I'll take a poll at the end of class. I'm happy to give you a lecture on Thursday morning. As if, any of you want to attend it, it is cool. It's just in the morning, 8 to 10 on Thanksgiving Day. Dinner is probably with, family dinners are in the evening. So you should feel free to take a class on Thursday morning if you want. Chances are we'll complete the program. We're going to be, I have in mind so far, I think we will be able to complete the program today. Involves pointers and file input IO also, right? File IO is actually part of the CID, I believe. I haven't checked because the last time I checked, the file IO was, I think it was part of the CID, or maybe it wasn't, but some of the instructors were teaching file IO, file input and IO, but we weren't doing that in C++, mainly because it is pretty straightforward, right? It's like 10 minutes. If you know how to do C in, C out, console input output, file IO is very straightforward. So that's what we'll do. And we didn't actually cover that formally in class previously. But today we'll just fold it into what we're going to do, right? We'll fold it into the project that we're going to work on today. It'll be cool. And that and pointers and vectors. Actually, you know what? Today's program, the more I think about it, the more likely it is to be like a real program that you can actually share with the whole world and say, this is actually a really cool thing that people can do. And in fact, I think that this would actually be a very nice game to play over Thanksgiving dinner with your families, your extended families. And I think this would be a really cool game to play. If you can, I'm pretty sure you can play it on an iPad or any device that connects to online GDB. Well, okay, maybe not online GDB. You need to have a file because we're going to feed. Well, technically, you don't need to run it on a separate computer unless you want to do file IO from. Well, even on devices, you can do file IO, but it's more involved. Okay, all right. So you can play it on a laptop. Okay, if you have a MacBook Air or Chrome laptop, you can take it to your dinner table and it will contain this game that we will develop today. Hopefully complete today. Or if not, we'll easily wrap it up on Thursday morning, okay, in the first 5 minutes, I think. And you should be, and it will be a very engaging game for people to play, not just people who know computer science, okay? I think it's a word game, like Wordle and things like that. And so people generally naturally have an inclination to play word games, right? That's why people are crazy about crossword puzzles and things like that. So we'll do that today. Okay. All right. So we can start again. We can start at 8:10. We want to start sooner today, okay? Because I think this program is slightly more involved than previous classes. So let's start slightly sooner today at 8:10, right? In 4 minutes time from now, not 8:30. Well, I don't know when we started before. I think previously we used to start at 8:20, 8:30 or something like that. Let's start at 8:10 today. And then start coding, okay? And hopefully someone who hasn't coded before, and it'll be a slightly longer program, so keep that in mind. I think who hasn't coded so far? I think of the people I see on screen today, Adam is the only one who hasn't coded on screen before. Yes,
I did code that one week where we did the type racer that we ended up scaling back on the next class. That was me.
Oh, that was you. Okay. All right. Who else? Who else hasn't coded on screen today? It's so incredible, this class. I love this class because every single one of you, every one of you almost, okay, every one of you has actually had a chance to code in public. It's essentially in public, isn't it? Because we are coding on screen in front of your classmates live. And it's on YouTube. People can see you code. And so I'm so very happy to see all of you just dive in and code. And I've never ever had this experience in a face-to-face class, because in a face-to-face class, you can tell people, you know, you have to code this, and some of them are coding and some of them are not, and some of them are watching YouTube. And it's hard to go around and check and keep tabs, or not really keep tabs, but make sure that people are all on the same page. But here, even without me doing that, you're all just interacting with each other, helping each other succeed. Yeah, which is something I've not seen in previously in my own classes, and I have never seen this in any of the other classes, not just in here, even in high school classes. Okay, when my kids were in high school, too, very few people have the mindset to help their fellow classmates. They just want to, if they know something that can get them an edge over the others, they'll basically just keep it to themselves. And I don't see that here. And in fact, if you go to the CS2C, right, CS2C is actually very challenging and also a competitive course, because lots of people are competing to get top grades in CS2C, not just in my section, anywhere, right? Because CS2C is really one of the marker courses for industry out there. If you're really a top dog in CS2C, the confidence level is over 90% for a hiring manager that you will be a solid hire. Because they just need to check out your personality and all that, because they know you're technically solid. So it's a really competitive class. But even out there, just go to the CS2C subreddit and you will see you guys, essentially, you guys in a couple of quarters doing CS2C. Essentially your classmates, they are helping each other out on these intricate problems that you can see. Well, I got that, I got past that problem and I've now got full points. Now, I'm pretty sure a lot of people are going to get stuck and they're going to die on with that bug. You can know that because you almost died with that bug. And you see other people are going to die too. And I'm going to have fun watching them die, and I'll get my A+, and those guys are going to be groveling around, in C+ land. But that is not the attitude, right? Everybody in CS2C wants everybody else to succeed also. And they're out there looking for, people getting stuck with these little things that they can't see, and say, well, I'm giving them hints, saying, well, go and take a look at that. Go and take a look at that. That'll help you, right? And they're helping each other pass. That is so fulfilling. Sorry? Oh, I'm sorry. I missed the last thing that someone said. Was that a question for me or? No? Okay. All right. Okay. All right. How about someone take up, what time is it now? 8:10. Yeah. Okay. All right. Okay. So here's the game I have in mind. Okay. So I had this idea on Thursday, no, Friday. I was sitting out there in the orchard, and and I've been very eager to say, all right, let's try this on Tuesday, and hopefully we'll have something. Well, I had to think for a little bit to see how I can work pointers into this, because today's class is supposed to be pointers and all. But I think I have a way to do that, and we'll find out. The proof is in the pudding. We'll find out today, right? We'll try and do it. And it'll be very straightforward. It'll be, I think, maximum of 200 lines of code. Okay, you've already been coding 150 to 100 to 150 lines of code in our class, and now you'll have an opportunity to code slightly longer. It's not bigger, huge. It's 200 lines, but it'll still do something really, really cool. Okay, yeah, and so how about? Hey, Leonardo, you're here. You said you can code today, right? And by the way, you should all feel free to switch on your cameras right now, okay? So now is the time you can switch on your cameras so that we can all see your face, because it's important for other programmers to see your excitement, right? Because if people look at this video and say, these are people learning computer science, and look at their faces, they're like, they look like they want to go back to mommy, right? And nobody's going to want to learn computer science after that. Okay, but now I see you guys, you're all engaged and energetic and enthusiastic about this thing. That means that other people have to see your face. Then to say, hey, you know what is that guy doing? I can't see what he's doing, but I can see his face, and he's so happy. Nemo's like smiling away and all, right? I need to do what he's doing. Okay, so that kind of attitude. So please switch on your cameras, and let's have a blast. Okay, and we don't have that many classes left, so it's up to you to make the most of these things, and also showcase your talent, showcase everything that you are able to bring to the table, so that everybody else can also enjoy and partake in it later on. Okay, all right. So Leonardo, if you are ready, by the way, before you start, let me decide what platform we're going to use. Have you used Xcode or VS Code? By the way, which machine do you have? You have a Mac or a PC?
I have a Mac.
Great. Okay. All right. So we'll fall back on Xcode. Have you used Xcode before?
Not really. No.
Okay, all right. So how about it's very simple. Okay, if you can program in C++, your hex code is like a piece of cake. You can actually pick it up very easily. Well, the bits that you need to get going, you can pick it up easily. So would you be willing to code on screen today using Xcode? I'm going to walk you through this, and by the time, after 5 minutes, you'll know what Xcode is doing and how to do everything. Okay, are you okay with that? Great. Okay. So what we need to do is essentially start up Xcode, empty Xcode. Okay, empty, no project at all. Just fire up Xcode and share that screen, just that Xcode window. Share it, and then we'll take it from there. Okay. And again, it's a reminder. Please do switch on your cameras, guys. Get ready to switch on your cameras if you're not already in a camera ready situation. Please do switch on your cameras, and then we can. And that will give Leonardo some Leo or Leonardo. I think Leo, is Leo okay?
Leo's okay. Yeah.
So yeah. So while Leo is getting ready to share his screen, please do switch on your cameras, and then we will start coding.
Oh,
Okay.
I'm sorry. So I can't, for some reason, like I can't download Xcode because my Mac OS version
What
is
do
out
you
of
mean you have?
date.
You can't. Why does it say you can't?
I haven't.
Why does it say you need to Xcode download something? You already have Xcode on your Mac, don't you?
Oh, is it?
Hmm?
I don't have it downloaded.
Oh, you don't have it. Oh, wow. Okay. Well, let's not use Xcode then. Okay, let's not use Xcode because it'll take 20 minutes to download, I think. I don't know what your internet speed is, but it may take up to 20 minutes to download. What we can do is, are you familiar with any text editor? Any text editor on a text edit or something like that? Can you open up text edit?
Yeah.
All right. Okay. Because we're not going to use Xcode, we're going to compile things by hand on the terminal. Okay, on a Mac terminal. It's a pity, Leo, because if you had Xcode, this would also be a training run for your Xcode, right? Because I'd walk you through Xcode, and by the end of this class, you will be intimate with Xcode. You know exactly what to do, right? Maybe in a later class we can have Xcode and we can work on a small project. So what we'll do today is just open up a text edit window. What other editors do we have? By the way, I see. Yeah, kill that. And then hit Control+ a couple of times. Okay. No, yeah. All right. No, that's too big. Control- a couple of times. Right. No, type a few characters and then hit Control+ or minus. Then you'll have a much better idea of what the size is going to be. Yeah.
Is that good?
Yeah. One more time. One more Control-. No. Leave the letters there and hit Control-. Type some junk.
It doesn't adjust it. It doesn't.
Oh, it doesn't do it live? Oh,
I have to
wow.
highlight it and then do that. It's weird. I don't.
Oh, that's interesting. Okay. All right. So here's where we're going to code. Now, is your desktop clean, right? Is it just before you share it or not? Okay, so I just want to make sure that your desktop is clean before you can share it. You don't have to share it right now. There will be a time when you have to share your desktop. Is your desktop clean enough to share, Leo?
I mean, there's like not important files on.
All right. Okay, so you're okay with sharing a desktop. Okay, good. So just before you start typing in here, just create a folder on your desktop called call it Anagram. We'll just call it Anagram for today. Okay, we'll call it Anagram. Create a folder on your desktop and call it Anagram. Anagram. Yeah. Now you can leave it there. It's yeah. Why does it have all these files in it? It's an untitled folder,
no, that
and it
was
has
just of the desktop, I think.
Oh, that was just the desktop. Oh, I see. Okay. All right, great. Okay, so here is where we're going to build this project that we're creating today. Okay, so open up the file. Open up your type in our standard comments at the top. What do we do? Class code for so and so on and so forth. Okay, me switch to gallery view. Oh, it is on gallery view. So all right, good. That's good. No, and put comments right at the top. Oh, gee, actually, text edit is such a pain when you try to write code in it because it automatically capitalizes some things. If someone can Google and find out how you can disable that in text edit to say how can I disable? Yeah, see, using why. Can you go to edit and say, is there a preferences, maybe preferences, and say autocorrect, turn off autocorrect in preferences. Autocorrect. Is there an autocorrect option? Or just Google and find out how to turn off autocorrect in yeah, check spelling, check grammar. Yeah, that's good. That's good. Yeah. And also before you do anything, smart quotes and clashes, dashes and RTF. Yeah, that's good. And also go to your format menu and change everything to plain text. Okay, format change to plain text. Make plain text. Make plain text. No. There you go. Make plain text. Great. Okay, now that will make sure your document is an ASCII document. Now you hit Control plus, Command plus. Now let's see if it makes a difference. There you go. All right. Previously it was an RTF format or something, and that's why I didn't do that. Yeah. Okay. Now put comments right at the top saying today's class code and today's date, and then you can say we're going to build a game called Anagram for families to play during Thanksgiving dinner. Okay. All right. On the next line, we'll program a game called Anagram for a game called Anagram. Called Anagram for families to play for Thanksgiving dinner. For Thanksgiving dinners. For people to play during Thanksgiving dinner, right? For you can say people to play, right? Because it's I get invited to Thanksgiving dinners with friends too, right? So okay. All right. So and then we'll also say what this game is going to do. All right. One more. How this game is played. Okay. So on this line, how to play this game, colon, and then on the next line, how this game is played, colon, played, colon, on the next line. Yeah. More comments. And you say in each round, a player will get given a jumble of letters. They need to unjumble into a word, and they get 5 tries. We'll get 5 tries. Yeah, we'll get 5 tries to unjumble a a player will get so we'll change it. In each round, a player will get 5 tries. In each round, a player will get 5 tries. In each round, from the beginning. In each round, a player will get 5 tries. A player will get 5 tries to unjumble a jumbled word of n characters, of length n, of a jumbled word of length n. N, right? And the next line, if the player passes around, they advance to the next level, in which the word will be slightly longer. Okay, and so essentially what's going on is that you first you get a 3-letter word that you have to unjumble, and you get 5 tries. Obviously you can get it right. Okay, and then if you pass that, you get 4-letter words, and you got 5 tries. Then 5-letter words, 5 tries. And eventually, you get, 15-letter words, you got 5 tries to unjumble. Nobody's going to get there. But you can actually, that will be a very catchy game, I think. Oh, I've never played it, obviously, because we haven't coded it. But I think if you code this game and play it over a dinner table, it'll actually be very catchy, because people will say, well, I got to level 7, right? I could unjumble a 7-letter word, right? And someone else said, I'm going to get to 7 too, because I'm getting stuck at level 6. I think it'll be a really cool game, okay? And even if you're on a plane, you may have to travel for Thanksgiving dinner, right? If you're on a plane, you could actually have your laptop open and play this game. And I bet the person next to you will say, you know what? I know what that word is. Let me help you out. And they'll also be willing to play, right? So your co-passengers will be willing to play. I know this because one time I was flying back from New York, right? And I was really bored. And the person next to me, she was playing this game. I forget the game. It was a game on an iPhone. and it was a word game, and you have to unjumble letters. And she was stuck on locus, Locus. And it was jumbled. It was 5 letters, and she was stuck, and she was looking at it for a long time. And I saw it, and I could say it was locus. You know, you can get past and go, because I used to play that game too. So I could see unjumble it in my mind. But she was stuck there, and I was so tempted to say what the word was. But you know, that obviously is like question. You don't want to give the answer out. So I just had a lot of fun trying to unjumble these letters in my own mind as she was playing the game. So I think that if you play this game with other people, they would actually love that. Okay, all right. So let's go ahead and, you know, here are the cons of trying to code on the fly without having coded it before and thought about it. So I'm going to have to think for a few seconds. Okay, so what we'll do is, okay, all right, so we'll do it this way. All right, okay, so we are going to create a class called Anagram, okay? So let's create a class called Anagram, class space Anagram. Oh, did it automatically capitalize the C?
No, I didn't.
Oh, okay. All right, and capital A for Anagram because it's the name of the class. And then space curly brace, and then further down, close it, right? Semicolon at the end, semicolon after the end of the curly brace. All right, so here, let's do private colon. No, you got to get over the get out of the habit of capitalizing.
Sorry.
Yeah, okay. So on the next line, indent in, and you're going to say vector. Here is a new concept, okay? It is going to be a vector of vectors. It is a 2-dimensional vector, okay? Are you guys comfortable with this? I'll explain everything. Right? It's going to be very simple. It's a 2-dimensional vector, but we're going to implement a 2-dimensional vector using pointers. Okay, it's actually a pretty sophisticated concept, and it's going to be serving you really well in CS2B, CS2C, in your life as a programmer. Creating 2-dimensional vectors with pointers is a really powerful skill to have, and it's so super duper easy. So that's what we're going to have, right? So vector, and inside you're going to say vector again. And then open angle bracket. Now it's going to be a vector of strings. So you're going to say string inside there. Okay, and then close again, right? And now, and you can say, yeah, we need to come up with a name for this. Word lists. Okay, word lists. Word underscore lists. Yeah, okay. Or you can use camp. Okay, camel. Yeah. All right, okay, semicolon, and let's put a comment on top of this. Yeah, okay, maybe there. Yeah, okay, all right, good. So this. Oh, you have to indent in both of those. Yeah, be indent in both. Even the vector thing needs to be indented in. Why is it indenting by 8 spaces? Is that 8 spaces? Just indent by 4 because we'll have more indentation later on. Don't hit tab. I think you're hitting tab. Just hit 4 spaces instead. Okay. All right. So comments. We want in the comments. We want to say this is a list of word lists. Word lists. Okay. Not quite as big as that. Okay. Word lists. And each list contains words of a fixed size. Okay, on the next line you're going to say example eg dot, right? Word list square bracket 2, and a word list square bracket 5, right? Let's say word list square bracket 5 equals is a list of 5-letter words. Is a list of 5-letter words. Right, and on the next line, to say one more comment, please. Yeah, thank you. For readability, we will avoid using word lists of 0. Okay, so essentially we'll only start filling in the words with 1-character words and so on. Okay, all right, that's all. Word list square bracket 0. Yeah. Okay, great, great, great. Excellent. All right. Now let's do the public methods, right? Let's do the public methods. Blank line and then do public. Yeah, blank line. All right. Now indent in under that, indent in. Now the first thing we want to do when we have this class, see, we're designing this in a slightly different way. Because previously we used to do things top down, right? So top, yeah, write the main and then fill everything out. Here we're doing classes and then we'll do the main later. So you'll find that a mix of these things, strategies, is what programmers generally use in real life. So it's up to you. You can decide when you get to coding, you can decide how you want to do these things. Okay, first let's do the constructor. Okay, constructor is just going to be anagram, no, uppercase A, anagram, and then open parentheses, and then you say string space file name with all words. Okay, file name underscore with underscore all underscore words. Okay, and as a close semicolon. I think you need to fix the typo in file name. Okay, great. So what that is going to do, the constructor is going to take a file as a parameter, and it's going to read the file, and the file is going to be like a dictionary. It'll have all kinds of words in it, a and the, Leonardo. If you're doing, if you're going to include names of students also, but let's say it'll have everything in it. And so the constructor's responsibility is to open the file, read all the words one by one, look at the length of the word. Okay, and if the word is 3 characters long, it needs to stuff it into word lists of 3, right? If the word is 5 characters long, it needs to stuff it into word lists of 5, and so on. Okay, that's all it's got to do, and it's got to do it for all of the words, right? So that is the overall logic. We haven't coded it, obviously. We're going to code it, and just raise your hand if you think if you can see, or if you think that what I just described as the job of the constructor, right? It's got to open the file. Forget about the difficulty of opening the file and all, okay? I'll show you how to do that. Just assume it's CN, right? Tell me if the constructor logic, the logic of the constructor, where it just has to read a list of words from a file and stuff each word into the appropriate bin in the vectors it's got. Okay, that's all it has to do. Now, is that reasonably straightforward logic? I'm asking because that way I don't have to we don't have to belabor that point anymore, right? Otherwise I might end up talking more about it and waste time. So if you think the logic is pretty straightforward, we'll just move on to some of the other methods now. When we get to implement it, obviously we're going to talk more about it, right? But I just want to make sure that this is pretty straightforward. That's all it's got to do, okay, in a constructor. Is that reasonably straightforward, that part of the logic? Because if that is easy, the rest of it is a piece of cake. Okay, and in fact, I suspect that we'll probably be done with this program in half an hour. Okay, well, famous last words, but I think it's pretty straightforward. Okay, that's all we got to do. Is that okay? Is the constructor logic okay with you guys? Raise your hand. Good. All right, excellent. All right, now now that we've done that, on the next line, let's also define the other main play method. And the next main play method, the public method, the next main public method is going to be called play. We'll just play, right? Once you've read the words, you're going to play. That's it, right? Play and open, close. And then play is just going to return, let's say play will return void for now, okay? Let's say void. Yeah, void play. And the reason I say for now and things like that, you may see that there may be some other instructors or teachers, I don't know, depending on style, they'll say, even before you write that, you already need to have in your mind, everything planned out. You need to know exactly what it's going to return and shit like that. Okay, yeah, it's different styles of programming. So you got to, but I've worked with top programmers in the world, really, and I've seen them coding side by side, and they don't do things by the book every single time. They do things that are needed for the moment, even though it may be against the rules of what they've been taught in kindergarten or school, right? Because the expertise comes with knowing when to break rules, right? People can't say, I have all the power in the world, I'm going to go break rules all over the world, right? All over the place. Yeah, unbridled freedom is really no freedom at all. You'll find, right? In real life too, if you have total freedom, it is equal. It is equivalent to having no freedom at all. Freedom with direction, saying, well, you have the freedom, but this way you'll find what you want to do, right? Then you automatically say, well, you know what? That is not free for me to explore, because if I go that road, down that road, I'm sunk, right? So that is guided and directed freedom. That is a great thing to do. So what that means in programming terms is that you will learn a lot of good rules, right? So even in other classes, you may learn, while loops. You should never use infinite loops. How many times have you heard that in other programming classes? I'm pretty sure I have actually been in a class where the instructor was teaching the students, this is a while loop, and you should never use an infinite loop. While true is not allowed. If you do that, you get a -1 in your assignment, right? And I actually saw assignments marked down by instructors for students who had used a while true loop. Why would they do that, right? In a perfectly innocuous context, right? Not in a place. So, and that is because people can be sticklers for saying, this is the rules. These have been laid down by people, and we have to unthinkingly follow them, right? And if you don't unthinkingly follow a rule that's been handed to you, you get a -1. You get a penalty. That is the stupidest way to, I think, right, to teach. Teaching, I think, you should say, well, these are the rules, but you'll find situations where you need to disobey these rules, right? So we're going to go back now. And sometimes after we implement play, we may say, well, you know what, it makes sense for play to return a Boolean. So we'll go back and change the void to a bool. And we've done that before in class, right? Even last class, I think we did that for one of the methods. So that's what we'll do. All right, so here's what we're going to do. Let's go and create the constructor. Okay, let's create the constructor. And let's, and on the next line, blank line after that. And then we're going to create the constructor. And the constructor is basically just going to be anagram, anagram. Okay, anagram, anagram. Right? Yeah. No, uppercase anagram. The constructor has to have the exact same name as the class. Okay. It's the same, yeah, that's what Ashley said in her post on Reddit a long time ago, right? So, all right, open parentheses and say string word file. Okay, call it word file here because we're going to call it word file. Okay. Oh no, file. Yeah, close, and then space, curly brace, and then close the function. And we need to go to Google for a sec. We need to go to Google, and in Google, open an incognito window, because when you're going to type a search there, we don't want to say, oh, what is the solution for question number 5, in your recent history, right? So we want to say common English words. List of common English words, list of most common English words. Okay, list of most common English words. We just want to grab any old list out there that looks reasonable, and we'll transfer it into a file. 3,000 most common words in English. Cool. All right, great. Click that. Yay! Fantastic. Okay. All right. Copy all of that. Okay. Copy all of that. 3,000 is cool. I was not hoping to get that many. And it's got to be common, because only common words people can unjumble in their minds, right? So if you give them a word that you've never heard before, right, and say unjumble it, yeah, I know, no success there. Okay. Now, great, excellent. Now, open up a brand new text. Go to your text edit. Yeah. Now, Command N to open a brand new file. Command N to open a brand new file. Make that plain text again. Make that plain text. Yeah, and paste all of the words in there. Great. What is that last? There's a space. Okay. Good. Yeah, that's fine. Oh, put the enter after the last word. I think zoom needs an enter. Yeah, great. Now, you want to make this is plain text for sure, isn't it? Did we make sure? Yeah, I think we made it plain text. Yeah. Now you want to save this file, Command S, and then you want to save it in the anagram folder. Okay, save this in the anagram folder. Yeah, and give it we'll call it. Let's call it. Yeah, well, word list hyphen 3000. Okay, word list hyphen 3000. Word list hyphen. You can use a hyphen. You can use a hyphen here for word list also. Oh, that's fine. That's fine. Right. .txt. Okay. Let's yeah, save it. Excellent. All right. Great. Great. Now, if you go to your terminal, you can close this window. You can close this window. Right. If you go to your terminal, yeah, hit enter. Now change into your desktop. So cd space tilde is your this thing here on in the left corner. Yeah, /desktop, capital D E S and then tab. No, capital D E S and then tab. Capital D E S and then tab. Yeah. All right. And capital A tab. Yeah. All right. Hit enter. Now hit command plus a couple of times to increase the size of this. Even one more time. Great. Now do ls space -l, and you should see that file in there. The file that you just created should be in there. Is it there? Yeah, it's there. Okay. Now, if you want to see what's inside this file, you can basically say page that file. You can say more space W tab, W and tab will autocomplete. Right? If you hit enter, you'll see what you just put in the file. It's all there, isn't it? Great. Okay. All right. So we've created a file. We grab data off the internet and put it into a file. Now, all we're going to do is simply read that file and take the words in that file and put them inside our vectors. Yes? In our constructor. Is everybody okay with this so far? Hey, Nemo, you're dancing around the room. Are you sitting in front of your computer and following class or not?
Yeah, sorry, there was just a bug on my computer.
All right, okay, all right. Is this a bug on your computer? Is it a physical bug? Is this at Foothill?
Yeah.
Library room?
Yeah.
Wow. Okay. All right. I know that because in my room, which is very close to the library, we had not my room, my neighbor's room. 4128, 4127, they had an ant problem. There were lots of ants in us.
Oh, really?
In her office. Yeah, I think it was Beta's office. Yeah,
No.
lots of ants. All right, good. So QQ will get out of your more paginator. Okay, now let's go back to your coder and to the code, and we're going to code this. Okay, so here is what we're going to do. The first thing we're going to do is basically open the file and read the file line by line. Yeah, that's all. So in order to read the file, what we need is a library of functions that are designed to deal with the file stream, a stream that is attached to a file, not a stream that is attached to the keyboard, right? CN is a stream that's attached to the keyboard. Later on, we also did a stream that was not attached to a keyboard, but it was attached to a string, S string. Now we have, in your quests also, in your experiments, you would have used S stream before. I think, right? S stream is a stream that is connected to a string. So you can send something and it'll go into the string, or you can read from the string also. So S stream. Now we're going to create something called an F stream. F, not S. F as in file. Okay. F stream. Yeah. Right. So F stream. And now inside of your method, inside of your constructor, you're going to say, I think it is IF stream. Okay. IF stream. Open parentheses. No, what you did was right. Space. No, yeah. Space. You say IFS, right? IFS, just IFS. Open parentheses now. And then say word _ file. Right? Okay, close. All right. So now at that point.
Quick question.
Yeah.
If we're using a vector, so should we also include vector at the top?
Yes. Thank you. Thank you, Thomas. Okay. Yep. So yeah, there you go. Excellent. All right. So now all we need is just to put a while loop in there. Okay. So enter a couple of times inside the method. Yeah. Now you're going to say while open parentheses. Let's use getLine. Okay. GetLine open parentheses IFS comma space word. Okay. Close two closes. Two. No, one more. You have two open parentheses. One more. and the unit space after that. So yeah, and close the while loop, and then we can go inside the body of the while loop and fill it in. Yeah, and close the while loop also. Close the while loop. One more. Yeah, indent in the. All right, good. Now we're using a string called a string variable called word. So let's declare that under if stream. Let's just declare that too, right? String space word. Okay. All right. Now the first thing we're going to do is read. Well, we've already read the word. Okay. Now we want to find the length of the word. Okay, because the length of the word is what is going to tell us what vector it needs to go into. If the word is 1 letter long, then it needs to go into the first vector. Word list of 1, right? If the word is 2 letters long, it needs to go into that, right? So that's what we're going to do. We need to find a word. So let's say if let me see. Okay, all right. Yeah, we need to do this. Okay, so if that's int len is size t len equals len equals word dot length. Yeah. Okay. Now what you're going to do is now you got the length of the word. Now you're going to check if your word lists has enough. Has that particular vector in there already. So what you're going to do is blank line here, blank line. Now you're going to say indent in if len is greater than or equal to, what do we call it? Word underscore lists dot size. Yeah, word. I think we call it word lists, plural, word lists dot size. Yeah, right. And no. Yeah, enter. You don't need braces there. And no, you don't need braces. It's just one line, right? Tab in into the if. Yeah. And you want to say word lists dot resize. Len plus 1. Okay. No, yeah, len plus 1. That means our corner case word if len is greater than. Yeah, I think that's that's fine. Okay, we'll check the corner case later on. Okay, I think it should be right. Maybe someone else who's not. Well, no, actually, nobody should check this right now because otherwise, then you won't be following along. Later on, we'll get a chance to check, check the corner cases and all. So don't check the corner case right now. We'll check it later on. Okay, semicolon right there. Now, on the next line, yeah, one more blank line, and then indent in, and start a comment saying, all we need to do now is simply stuff the word into no, you can actually say into word list square bracket len, right? Word list square bracket len. I think so, right? Because you resize it to len plus 1, so len should be there. Yeah, good. Right? Semicolon. Oh, I see. That's a comment. Okay, so now all you need to do on the next line is say we do exactly that. We just say word list square bracket len dot push back, right? Push underscore back. I think it's push underscore back. Well, we can find out, right? We'll find out later. Yeah, I'm pretty sure it's push underscore back. Okay. Open. Yeah, it is. Open. Yeah. Thank you. Right. Open parentheses word. Okay, all right. So the constructor is done. Okay, so the constructor gets given a file. It's going to read the file, take all the words, and stuff each word into the corresponding bin in our big word lists. Yeah, Adam, you got a question? Hey, Adam, I can't hear you. I still can't hear you. Adam, your microphone is off or something. Are you saying something? Adam, are you saying something at all, or can you hear me?
Oh, I was talking to Nemo because he and I are right next to each other.
All right, okay. Are you guys following class though? All right, cool. So is everybody okay with the constructor so far? Everybody okay? Raise your hand if you're okay with the constructor. We can go ahead and create the play method, which is for the game. Yes or no? Yeah? Okay, good. All right, so now let's create anagram double colon play, right? The method anagram double colon play. No, not there. Outside of the method. Outside, yeah. You can this one is done, right? You can get rid of the blank line also. You got an empty blank line there. Yeah. Right. So anagram double colon play. Right, and it's void, and so you can stick void in front of it, and then it doesn't take any parameters either. So you can open close right there. Open close and a space brace, and then close the brace. All right. So here is what we're going to do. Say int, you can say size t round underscore number equals 3. We'll start at 3. Okay, there's no use giving someone 2-letter word, jumbled 2-letter words and say unjumbled is 2-letter word. So we're going to start at 3. Okay, so that even kids can play it, but it's still mildly challenging for them. Okay, so and put a comment there saying start with 3-letter words. Okay, start with 3-letter words. No, on the same line is fine. On the same line, you can say comment start with 3-letter words. Okay. All right. So now a couple of blank lines, and then we can start our game. Couple of and then indent in. And what we'll do here is you can say let's do a while true here, an infinite loop, and then we can change things later on. How depending on how it looks. Okay. All right. So yeah, there you go. Thank you. Okay. So inside, what we're going to do is put a comment there saying select a random word whose length equals round number. Or you can say off length round number. You can use your own words. Okay. Yeah, with length equals round number. Yeah. Okay. All right. Great. And we'll actually create do we need to create a new method? No, we don't need to create a method to get that. We can just do it right here directly. Okay. So you can say on the next line, you can say string word equals word lists square bracket round number. And then remember, this is a 2-dimensional vector. Okay, so there's a vector which contains another vector inside of it. Oh, we never got to use pointers. Well, okay. Yeah, I wanted to use pointers. Well, we've got a chance to use pointers. Okay, if not, we'll find a way later on. No, later on. No, actually, after we complete this program, we'll go and change this to use pointers. Okay, change this to use dynamic memory and pointers, and also use that opportunity to create. We don't have to create destructors here, and you can chime in the Reddit as saying why we don't need that and all. Oh no, then we'll have to use destructors. Cool. Okay, so we'll get an opportunity to do all that later on. Okay, word list. Yeah, and close square bracket. No, you got open, close. Yeah, close, and then open again. Open. Here you're going to say, it's going to be ugly and big. I'm trying to think of a way in which we can clean this up a bit. 1 sec. Okay, I just want to think about something to make it cleaner. 1 second. Here's what I want to do. Right, let me do it the unclean way, and then you'll see it's dirty. And then we can say, all right, here's how we can clean it up. Okay, so copy that entire thing, word underscore list square bracket round number. Okay, the whole thing. Now that whole thing needs to go inside of the square brackets, the second square brackets. Is it all right? Yeah. Okay. Now get rid of the square. Get rid of the last closing, yeah, open, dot size, and before that, before, you know, round number, no, before word list, before, yeah, you want to go there you go. Okay, you want to say rand, open close, space, percent. All right, okay. Now actually this actually fit. Is it 80 columns? I think is that 80 columns? It actually fits in there. Close there. Close the square bracket, semicolon. Right. This is what I had in mind. This is what needs to go there, but we can make it easier to read. Okay. I think it is harder to read. Hands up if you think this is a you know, a Python of a messy sentence right there. Is that a really messy statement? I think it's messy. I don't know. Some of them maybe you don't, right? Adam, or do you agree or not? You raise your hand. Did you raise your hand or are you talking to Nemo? All right, looks like Adam and Nemo are having a private conversation over there. All right, you guys have to follow class. Okay, you got to be a part of class. Otherwise,
We're talking about we're talking about the code.
Oh, you are talking about the code. Okay, good. But it is a messy statement, isn't it? Because part of programming, also part of learning to become an expert programmer, is just training your mind to subconsciously spot messiness in code. Okay, the number one obstacle for experienced programmers in effective debugging of their code, you'll find, you talk to any experienced programmer and ask them what makes your code hard to debug. Okay, what is the number one thing that makes your code hard to debug? And I bet, right, 90%, over 90% of the responses you'll get from expert programmers is that messiness. Okay, if the code is messy, they will have a hard time debugging it. Okay, and you will find out, especially when you go to when you go to green and red. Okay, it is super duper important to write unmessy, clean code, and every statement should be as concise and clean and simple as possible, but no simpler than that. And because as it is, you're going to have a hell of a time debugging things in CS2C level, because in 2C you're going to be debugging things you can't even see, right? Not the logic, right? Because right now you're in 2B, you're in 2A, you're fixing syntax errors. 2B, you'll be fixing logic errors. Okay, logic meaning your logic is, your syntax is all right. I'm super solid on C++ syntax, but my logic is incorrect. So I need to figure out what's wrong in my logic. Okay, so that it's much harder than fixing syntax errors. There's something even harder than fixing logic errors, which you'll encounter in CS2C. Okay, completely different beast altogether. And that is when you have most likely have your logic right too. You have your syntax right because you know C++ inside out. You have your logic right too because you know the algorithm, and you know you've read through the mathematical proof. I can prove it. I can prove that this algorithm works with the guaranteed bounds and everything. So you know everything buttoned down properly. But still, you have another kind of error that is going to resist these two, and it's like super duper hard. And those are spatial bugs. Okay, spatial bugs are when you have your syntax right, your compiler can't have your back for you, your logic right, your debugger can't have your back for you. Now you have your spatial error, spatial bug, where you have a structure, a complex structure you've built in your memory, right? There's something here that points to something else here. That something points to here, and that something points back here. So you got a triangle in space, okay? And now you got to work on that triangle in space. But it's not a triangle really. If you look at it on paper, it doesn't look like a triangle. Does it look like a triangle? It's a triangle in space, right? It's a hyper triangle, but it doesn't look like a triangle. It's just a representation of a triangle. It's an abstract triangle in space. Yes or no? 3 points, just numbers in your computer. Yes, coordinates. They don't look like a triangle. Your triangle in your mind doesn't look like a triangle, right? This is neurons, right? This is activation potentials and things like that. It's not a triangle.
Working, but
so if you have a bug in structure, if you have a structural bug, even if your logic is right, even if your syntax is right, how can you find out? You totally sunk there, right? And that's the point where many C programmers dealing with high profile, not high sophistication data structures. That's the point many people give up actually and say, well, you know what, my logic is right and it still doesn't work. There's something that's going on and I have no way of finding out. And the way to get there is just to write clean code. Okay, if it's clean and you can see everything clearly, then you won't have spatial bugs as much, right? You'll still have them, but it's easier to fix. Okay, all right, so we're going to make this cleaner. Okay, so comment that line out now, comment that line out, and we'll say on the next line put a comment, on the next line put a comment saying we'll just do the following statement is just a cleaner representation. The following two statements are just a cleaner factoring. Okay, the following two statements are just a cleaner factoring of the above statement, above commented out statement, right? Above, yeah, commented statement, commented out, yeah. Yeah, all right, cool. Right, so now we're going to do on the next line, you're going to say vector of string, vector square bracket string, vector, I'm sorry, vector angle bracket string, angle bracket. Yeah, yeah, and then space. Here is a very important syntactical point, okay? You're going to say ampersand. Okay, ampersand word underscore list, not plural, one, okay, word list equals word lists, square bracket, what is it, round number. Okay, on the next line, you're going to say string word equals okay, now you can say word list, open parentheses, open square bracket, rand, that thing that we did before. Yeah, percent, word underscore list dot size. Okay, now what does that do? Can someone tell me what that statement does? I'm not going to say anything until one of you speaks up, okay? So someone tell me what that statement is going to do. Is everybody following along? You know, now when I ask this question and nobody answers, it feels like I've basically left you all behind, and I've advanced to this, coding line 50 or something, and you guys are basically checked out, right? If that's the case, then I shouldn't even be doing this class, right? Because it's pointless for me to just keep blabbering on and nobody really understands what's going on. Then, you know, what's the point? So I need to know if you guys are on the same page, everybody, right? Not just the people who already have experience. I need to know that everybody is on the same page. Okay.
Is this just picking a random word that's for sure within like this size scope? Because you're using rand, but that might produce a number that would be out of scope. So by using mod, you guarantee that you're picking a word of the appropriate size.
Yes. Right.
Okay.
So what that does, so what Thomas said is essentially, now the two things here, you see that ampersand on the previous line, word list, ampersand, that ampersand says word list is a reference variable. Okay, it is not a reference means what it's pointing to is the actual thing. Remember, passing parameters by copy and reference. If you have an ampersand in front of it, it is the actual thing, not a copy. So when I have a word list, maybe, you know, a list of 5-letter words, maybe it's like 7,000 words in there, right? And if I say my vector equals that vector, it's going to copy all of the 7,000 words and create a brand new vector for me. And that's also 7,000 words. That'll also work. It's horribly inefficient, really, isn't it? Because we don't need to be using that. So here we're saying, I don't want a copy of that. Just give me a reference. And so that tells you, you already have the word list out there. I'll give you a reference to an inner word list in there. That's all. It's not copying. It's like super duper important. Okay. Because, and the reason it's important is because if you didn't have the ampersand, the code will still work. It'll work, obviously, right? Because it's going to give a copy. It'll be slower. And that is the irony and tragedy of, you know, software engineering in the Bay Area today, right? Because I've also employed lots of people like that. And they'll create code that works. It works, okay, and you can send it out, and many times you even do the reviewers, right? You do pair coding or, you know, peer review and all. They look at the code and they miss these little things, and just the missing ampersand, right? Look at that, right? Just a missing ampersand, you missed it, and your colleague who is supposed to review your code and check it out and say, well, good for release. Okay, they also checked it out and they missed the ampersand. Now it'll work. It'll work and it'll pass through all of the test cases that your test department has, right? In a company, you know, the developers do this, and then the manager will take that and he or she will pass it on to the test unit, the QA guys, and say, well, you know, run it. And what do the QA guys do? The QA guys are not going to run it on real world data most of the time, right? They'll have sample data sets that are fixed in size, and they'll run it through the fixed data, and it'll all work on the fixed data. But on the real world, and then they say it works on the test data and release it. But in the real world data is not like capped, fixed size. Real world data is like huge. And when it comes to huge data, it'll still work, but it'll grind. It'll work grindingly slowly, okay? Because now it is copying all the big things over instead of creating references. Did you see the problem there? And these are problems you may not encounter for a long time, even after you start working, because these are very subtle problems. Just a missing ampersand, it doesn't kill your code, but just makes it slower, right? Inefficiencies, and today, you know, you can bet that if you go out in the Bay Area, even in the top companies, right? Even in the top companies, I'm pretty sure, go to Google, Microsoft, everywhere, right? There's bound to be a few places in the code where people have missed out these things. And it's just gone through, not that they willingly missed out, or you know, they just missed it out carelessly, right? And it is passed through, and there's inefficiencies in code all over the world, okay? And especially finance companies out there, maybe, I don't know, right? Maybe not finance companies, right? So not really hardcore tech companies. They have a lot of code that's running inefficiently, and they're just happy with it because it just gives them their buck, right? They say, oh, it works enough to make me a profit at the end of the day. And that is like saying, you know, I can make a profit of $10 million by mowing down 20,000 acres of Brazilian rainforest. Okay, so I get a couple of $1 million of profit. Yeah, so you know, I make profit. I'm going to do it. But is it worth it to make that profit? Because you just ran over. You created a huge hellish situation for a huge number. It's not worth it. So that is the reason why it is like super duper important to have like squeaky clean code as you're writing it, so that it'll all be easy down the line. Okay. So all right. So we've got the word. Now we've got the word. Now that we've got the word on the next line, where are we? Oh, you need string word equals. Wait a sec. Where are we? Oh yeah, we're here. All right. Okay. All right, good. String word. Now on the next line, hit enter a couple of times. Hit enter a couple of times. Now what we want to do, put a comment there saying we want to jumble the letters in the word. We want to jumble the letters in the word. Jumble. Yeah. In the word. Present it to the user. Comma. Yeah. Present it to the user. Present it to the user. Present it to the user. And on the next line, and give them 5 tries to unjumble it. Yeah. All right. Is everybody okay with this so far? Great. Excellent. I don't get the 2-dimensional part. Yeah, sure. Hey, Andrew, describe your question, and I will. What is it about the 2-dimensional part that you don't get? By the way, Andrew asked this question, and I just happened to see that. Well, before you start, Andrew, just speak up, okay? Because you said it in chat, and it was a total coincidence that I saw the message. And if you speak up, I will absolutely hear it. And although Andrew was the person who asked the question, I am pretty sure there's at least more than one person other than Andrew who also doesn't understand 2-dimensional arrays but didn't ask. Right? So just raise your hand if you do need clarification of the 2-dimensional arrays, right? Andrew's going to ask the question, by the way, right? 2-dimensional arrays, if you need clarification, raise your hand. Andrew, go ahead and ask the question.
I don't get how it's necessary in this sort of a situation, because it's a 2-dimensional vector of strings, right?
No, it's not a 2-dimensional vector of strings. So it is a vector of vectors. It's a vector of vectors, and each of those vectors is a single-dimensional vector of strings. So what we have here, strictly speaking, is not a matrix. A matrix, you can have a 2-dimensional array of strings. A matrix will have exactly the same number of entries in each row. Here, we don't know if every row has the same number of entries. Yes, because I may have like only 10 3-letter words, but I may have like 500 5-letter words. So I can have a matrix saying like, right? Yes or no?
Oh, so you're saying that that each of the vectors of strings that are inside of this vector can be used to hold different words of certain sizes?
Yes, yes.
Oh,
So
okay.
you have a vector that is actually a vector of other vectors. You have, so essentially what we have is we start with a vector of words, many vectors of words, right? We have a vector of 3-letter words. We have another vector of 4-letter words, another vector of 5-letter words. Okay, we have a lot of vectors like that. Okay, now so far is everybody okay? Right? We have a lot of vectors, Each vector has words of a fixed size. Now, I need everybody to be on the same page before we move on to the next page. Is everybody okay with that? Raise your hand, please. We have a lot of vectors. Yeah, okay, good. Now we have a lot of vectors. Now, there's 2 ways to do it. I can basically have that many variables. I can say, word list 1, word list 2, word list 3, word list 4, right? Because if I have word list 5 is basically a vector of 5-letter words. Word list 4 is a vector of 4-letter words. I can do it that way. Yes, but it's a pain to have that many variables. So I said, well, they're all vectors. So let me have a vector of vectors. So I have, word list square bracket 1 equals that vector. Word list square bracket 2 equals another vector. So basically I've taken all the vectors and made a vector of those vectors. That's all I've done. Is everybody okay with that? Is that clear, Andrew? Yeah, all right. Even if it's not 100% clear, you need to, if it's 0% clear, you need to speak up and say, I don't understand it. If it's not 100%, you're like 50%, 70%. If you keep looking at this code, do it on your own, it will click, okay? It'll take a little while, but because it's a vector of vectors, it takes a little while, but it's like super duper simple, right? Compared to the things you will be doing yourself in CS2B, right? In CS2B, you will be doing things that make all of this look like child's play. Really, right? I bet many of you are enrolled in my CS2B. I looked in my winter. Is it winter? Yeah, I looked in my winter enrollment, and most of you are in my 2B class, and that's absolutely fantastic. Thank you all for that. So which means we'll have another great quarter of fun, hopefully. But you will be doing stuff in 2B, right? Which makes this thing that you're doing today look like something you could have done in your sleep. Okay, so it is so simple, and that is why it's important. Even though it looks complex, 2-dimensional vector and all, super easy. Okay, you just need to devote a little bit of time, and if it's not, just raise this point in the Reddit or in a future class, and we can talk about this again. Okay, I hope everybody's okay on same board on board with this now. Yeah. Okay. All right. Good. So that's all we want to do. All right. So on the next line. Yeah, after unjumble. Yeah. Okay. So what we'll do here is yeah, okay, I think we'll do this. Right. So you say if underscore open parentheses, and then you want to say if vertical bar, not, right? No, not. If not, not vertical bar, yeah, exclamation. If not, play underscore round. Yeah, if not play round, okay? If not play underscore round. Open parentheses word, open parentheses word. Okay, did we get the word? Yeah, we got the word. Okay, yeah, close. On the next line, indent into the next line. And say see out, and then within quotes you want to say sorry, all tries exhausted, see you later. Exhausted. Yeah, see you later. Right. Semicolon. Yes. Close quote, semicolon. Endl. You need an endl. Sorry, endl. Now the if statement, put a brace. We need two in there. Okay, put a brace in there. Yeah, brace. Okay. Yeah, enter. And then what the second one should just be, for now, let's just say exit one. Okay, exit, exit, exit open parentheses one, right? Okay, so and the comment there is going to be if the user fails any round, the game ends, right? On the same line you can put a comment on the same line as exit, right? On the same line as exit, if the user fails any round, the game has ended, or game ends. Yeah, game ends. Okay, all right, great. Excellent. Now all we need to do is create the method play around, which is like I think it's going to be super simple, right? So in your class def under void play, enter. You say bool play around, bool space play underscore round. Okay, and then it's going to take a string word. Thank you, Leo. Right, it looks like you have a bit of programming experience already. Okay. All right, good. All right, so now we're going to go and create that method. So you can create that method on the next line. Yeah. Right, so you say bool play round, and it's given a word, string word. Yeah. Okay. And also, you know what? Just for the benefit of students who aren't here today, put a comment on the place on the line where you say string word. On the line where you say vector ampersand word list equals. Yeah. Put a comment on the right saying this is a reference. This is a reference. Look it up and then important. Right. Look it up and important. Okay. Look it up. Important. For exams, right? It's important for exams. People will definitely look it up, right? Look it up. Important for exams. Okay, good. All right. Okay. Now let's go to the method that we're implementing. String word. Yeah. Okay. Space curly brace and then enter. Okay. Good. Inside. Can you bring the whole thing up a little bit? It's at the very end is put a lot of blank lines below it, then it'll automatically. Yeah. All right, great. Now 4 spaces, indent 4 spaces in. Right. The first thing we're going to do is take the word and then jumble it up. Okay. So we're going to say string jumbled word equals string jumbled word equals. Right, and then say jumble, open parentheses, word. Okay, all right, good. So what that does is that is a function we're going to write, a method we're going to write, which will take a word, shuffle it, and give it back to you. That's all it's going to do, right? So that's all it's going to do. All right, so enter now, and then because it's play, it's going to be talking to the user. Okay, so one more blank line. And then you can say, well, we need one more variable. Okay, so let's say const on the next line. Yeah, on the next line, const space num tries, all uppercase, num underscore tries, num tries equals 5. Yeah. All right. Good. Now let's do one more thing. Where you have that ampersand word list, that line, turn that vector into a const vector because we're not going to change it. No, wait a second. Yeah, you can change that into a const vector. Okay, good. All right, thanks. Right, so const num tries equals 5. So on the next line after const word, all right. So we're going to say while we also need a variable. Const size t num tries, right? Const size t num tries. Const size t. And on the next line, we'll also say const on the next line we just say size t n tries, size t try num, size t try underscore num, try try underscore num equals 0. Great. Okay, now we can say while try num is less than num tries. That's our loop. Okay, great. Now we're going to say in here, we're going to say, we're going to read in the what the user said, right? And before we enter the while loop, we need to tell the user what the jumbled word is. So, before you go to the while loop, on the line before the while loop, hit one more enter. Yeah, yeah, and one more. No, there you go, there you go. No, what you had before was right. So you're going to say cout, left shift, and then within quotes, you're going to say unjumble this, all uppercase, unjumble this. Yeah, that's fine. Unjumble this, colon, space. All right, and then left shift the jumbled word and end L. End L. Okay, semicolon. All right. Now, while try num is less than num tries, what you're going to do is read in. So the first thing you're going to do is print the prompt on enter. Yeah. Now, yeah, indent in. You're going to say cout. And you can say try within quotes. You can say try open close quote again, close quote, and then left shift I+1 within rather than do I+1 and all, just start try number at 1. Don't start try number at 0. Start it at 1. Try number at 1. Okay, yeah, try, and then yeah, now you say try num, like try, and then try num, and then left shift within quotes colon space. All right, that's our prompt. Right? Semicolon. No endl there, because you're going to accept input on the same line. Yeah. So, and you can say try num, and you can, yeah, that's a prompt. Okay. Yeah, I'm thinking instead of just saying try, let's say attempt. No. Yeah. Let's say enter. Guess. Yeah. Say guess unjumbled word. Okay. Guess unjumbled word. Full stop and then try num. Yeah, I think that will be better. On the cout line, yeah. Guess before try. You say guess unjumbled word. Or you can say your guess. Full stop, and then try, and then after try space put a hash mark, so try number, right? No, try space and then put a hash pound sign right there. Yeah, okay, good. So in your mind it'll look like, try number 1, try number 2, and so on. Okay, and then also try num less than or equal to now, because we changed try num to, yeah, try num less than or equal to. All right, great. So so now you can do your get line, right? Get line cin comma guess, guess. So we need a variable called guess, and it's string type. Okay, string guess. Yeah, great. All right, now we've got the user guess. Now on the next line, you're going to say, on the next line, one more blank line there will be nice. So if guess equals word, curly brace, and you can say cout hooray. You advance to the next level, or you advance to level. Try num. No, you advance to. No, you just say advance to the next level. Because we don't have the level number here. We can find out what the level number is because it's equal to the length of the word, but let's not mess with that. Okay, right? You advance to the next level. Then forget about try num and all. You just say you advance to the next level, and then return true, right? full stop, and then endl, and on the next line you say return true. Yeah. Okay. Now, if they haven't got the word, it's going to go back to the loop again. Increment try num. So yeah, outside of the if statement, after the if statement, you just say try num plus plus. Yeah. Okay. So and push it in. It's you need to indent it. Now, this is done using a while loop. This can easily be done much better using a for loop. Hands up if you agree or not. Right? And you can do this with a for loop yourself. We're not doing that because it's pretty straightforward. By now, you should be able to do it easily. Because you can do it because try num is being incremented here and then declared there, and then in 3 different places is a mess, isn't it? So you can actually do it in a for loop, saying for try num equals 0. We're not going to do it now. For try num equals 0, try num less than num tries, less than or equal to num tries, try num plus plus. You can do it like that too. Yes? Yes or no? Yeah? Nobody's even responding. Okay, you guys are already in holiday mode or something like that. You shouldn't, right? Because this is actually fun program. Okay, you'll have a great time with this program, I'm pretty sure. Okay, so what we'll do is let's put a comment because you guys are not speaking up. Let's put a comment. Try and advance to the next level. Okay, so above the on the while loop, right, on the same statement as a while loop, right? Yeah, above the while loop, right? Put a enter one more enter, right? And start a comment above the while loop and say, and this can be done cleaner with a for statement. Do it for homework. With a for statement, with a for statement. And then you can say homework, right? Within parentheses, you can say homework. Okay, all right. Now, after the while loop, at the end of the while loop, after the while loop, enter. Now you say, now that person, if someone gets to that point, that means they haven't got it. Even, they've exhausted all the tries and they didn't get it, right? So you return false there. Okay, now let's go back to our play method. We need to change, we need to embellish that a little bit. Now, if they successfully played around, what do? We go to the next level. Yes. So, and how do we know what the next level is? Round number increases. That's all. Okay. So, if not, then you exit the game. If outside of the if statement, you just say enter, and you just say a plus round number. Okay, plus round number. Okay, I think it's round underscore number, right? Now, so please check this code in your head because I'm obviously just coding off the top of my head, and you guys are also typing it. We haven't compiled it yet. We don't know if it's going to compile and run, and so it is up to you guys and me also, obviously, to look at the code and make sure there's no glaring obvious errors in here. So please do look at this and see if the logic actually works. Okay, so here's and everybody with me, not just me. Okay, so if play around and then all tries exhausted, it'll exit the game. If not, it'll increase the round number and then go back to the top and then get the next one. Oh, yeah. Okay, after plus round number, we need one more thing. Okay, now, yeah, after now you say if round number is greater than or equal to word lists dot size right, open curly brace and say and here you can say cout you say you ace the game, and there I don't have any more words for you. Congrats. Okay, you ace the game. No more words for you. Congrats. Yeah. Okay. right? Close end of. And then you can say return 0. On the next line, you can say return. You can say exit 0. Exit 0. That is the end of the game, right? Exit.
So, Professor, do we use exit 1 above to indicate error, and here exit 0 to
Yes,
indicate
yes.
that there were no error?
Yes, thank you. Yes, Mark, that is correct. Okay. Now, exit is a strange method because it's a strange function, because the value that exit returns, the inside the parentheses 1 or 2 or whatever it is not returned to main. It is what main returns to the operating system. So remember how your program runs. Your program is on disk. It is stored on magnetic media, right? It's on disk. The operating system, which is Microsoft Windows or Linux or Mac OS, whatever it is, right? Or even your phone, Android, the operating system is going to grab those bytes, load them in memory, and say, go and run your program. It's out there. Now, when that program completes, it needs to tell the user whether the program succeeded or not. However, when the program is completed, it means main has also ended, because only when main has ended, the program completes. Yes. So if main has ended, how can it signal back to the user? So the way it does that is main will return a value. So when you say return 0, return 1, that's the value returned. But what would you do if you have an inside method that needs to return to the operating system without going through main? That's exit. Exit is a short circuit return directly back to the operating system. It'll bypass main, return the value to the operating system, right? It's a special function, right? That's why I didn't, waste time talking about it. But that's essentially what it does. Mark, did that answer your question?
Yeah, so if we didn't want to end the program, we will have just returned false instead to main, for example.
No, if you want to end the program, there's two ways.
No,
Either
not
you can
end the
do any
program.
return from.
So not end the program, for example, send back to main that the method or function didn't work or there was a failure. It'll just return
Yes.
false, right?
Yes,
Not end the
yes. If you
program.
want to signal back to any part of your own program, you need to return the value. But if you want to say, I don't want to talk to my program anymore, I just want to talk back to the operating system and say we're done, then you use exit.
Okay.
But when main does a return, it's the same as exit. Main, when you have a return in main, it is exactly the same as exit.
Right,
Yeah.
because it's the last program basically, or the last.
It's the last function. It's the last function. It's the outermost function. Yeah. Great. Okay. Now there's one method we need to complete, and then it's ready to run. What time is it now? We have a lot of time. Okay. In fact, we'll have a lot of time to play this game too today. All right. So what is the one method that we need to complete before we can run this game?
Jumble.
Jumble. Yeah. Okay. So, all right, let's create the jumble method. Yeah. After play round, you can create, you can say void. No, not void. It's a string, jumble. What do we call it? Just jumble? Jumble, yeah, okay. Jumble, string, and yeah. And in fact, here, don't say word, you can just say str, because you can jumble any string, right? Because jumble is a general purpose. It doesn't need to be given a particular word, right? Str, right? So now we'll define the method. You can define the method anywhere you want. Okay, and then you can say string, anagram, :jumble, string, str. Yeah, okay, great. Now let's put a comment. Well, the name of the method is self-explanatory, so let's not put a comment right there. So, oh yeah, we'll put a comment saying what we're going to do, right? So to explain what we're going to do, right? We will iteratively swap every letter with another random letter in the string. Swap, SWAP. Every letter. No, not every letter with another random letter. Okay. All right, good. So now we can do the for loop under that. You can say we need to create a string that we're going to return. Say say string space result equals double quote empty. No, actually, you know what we'll do? We'll just set it to str. Set it to str. Yeah, great, excellent. Right now, enter. One more enter. You say for. For size ti equals 0. I equals 0. Semicolon I less than str dot length. Yeah, I plus plus. Right on the next line, we're going to say, yeah, thanks. Okay. So you're going to say, you're going to swap 2 letters. So we won't write a separate swap method. We'll just code the swap method in line and say char temp equals str square bracket I. Yeah, and then size on the next line, size t j equals rand percent rand open close percent str dot length. Yeah, str dot length open close. So that gives you a number between 0 and the length of the string, right? And on the next line, you're going to say one more blank line there, and one more blank line again, one more blank line, and then, yeah. And then you say open a comment and say swap the characters at locations I and j. Yeah. Now let's clean this up a little bit. When you have that temp equals str of I, cut that line and keep it in your clipboard. Cut that line and keep it in your clipboard. Okay. All right. Now, so after the comment you created, swap the characters on the next line. You're going to say, yeah, temp equals. You can paste that line. You can paste that line. Yeah. Okay. On the next line, you're going to say stir square bracket I equals stir square bracket j. On the next line, you're going to say stir square bracket j equals temp. Now that completes our swap. Yes, that'll do the swap. And when we've done this for all of the characters, the words will be jumbled. Yes or no?
Yes.
You guys have to. All right, okay.
We're
All
nodding
right,
along. I just don't think you're seeing our faces, but like most of us are just.
Oh,
like,
is it right? Hey, yeah.
non-verbally.
Thank you, Thomas. Okay. The reason I can't tell so clearly is because all of you guys are like a little stamp size. Because I'm looking mostly at the letters, the code that is occupying most of my screen. Thank you. If you just say yes, and that's good enough for me. All right. Now you say at the end, you just say return. Oh no, and I see. I'm so sorry. Inside the for loop where you have str. Oh yeah, right. We don't need that. We don't need that result variable at all. It's right. We just get rid of the result variable on. We can just jumble because it's passed by copy. You already get a free. Great, and then take that comment you have. We will iteratively and put that on top of the function itself. Blank line and then blank line, yeah, and no, yeah, and then great. Okay, so I think, and you can remove the blank line after the function started. There's a blank line before, right? Okay, I think, and then you return str semicolon, and there's a space before the return. Get rid of the space. Okay, I think all we need now is just a main to invoke our play method, and we're good to go. We're ready to play the game. Okay, so let's write a main at the very end. Now, the way that, because it's a class above that, I put a 2 forward slashes, start a comment, and then lots of hyphens, because below that we're going to have our main, right? Lots of hyphens. Okay, yeah, enter. Now you say int main, right? And then open, close. Yeah, curly brace. And then, yeah, here, by the way, when we read the words, what file are we reading the words from? What file are we reading the words from? Oh, we're given the name of the file to read. Yeah. No. No. I mean, in the program, we're given a file name, right? So, all right, good. I think we're given the name of the file to read and the constructor. Okay, all right, good. So, so go to your main, and you can essentially just right there, you can say anagram, yeah, indent in, and you say anagram space, lowercase anagram, open parentheses, and then within quotes you give it the name of the file, within quotes. Word, word underscore list hyphen 3000. You can turn all of them to the same underscore hyphen. Yeah, but that's fine. 3000 dot txt. Close. Right on the next line, you're simply going to say anagram dot play. Open, close, and then that's it. Return 0, indent in. I think that's it, right? That's it. I think it is ready to go. It is. We can play this game right now. I think, famous last words. Like I said, we haven't compiled it. We don't know how many lines is this. Probably 125 lines, maybe. You will find out, right? Save this. Is it saved? Oh, save it as anagram.cc, right? Anagram.cpp. Okay. Now let's go to your terminal, to this folder. Excellent. Yeah, can you increase the size of this terminal and also increase the font size now? It'll be better. There you go. All right. Now hit Control L. Let's go to the top. Hit Control L. Yeah. Okay. Now let's see. Do an ls-l first. ls-l. Up arrow will get you that. ls. Yeah. ls space -l. Same as up arrow. Yeah. Okay, there you go. You see that anagram.cpp, that's a file that you just saved. Let's find out how many lines it's got, right? Say wc space -l, that's word count -l is lines, right? Space. No. Control C, up arrow. No, Control C. Great. Up arrow. Space. No, only one up arrow. Now down arrow. You can do down arrow. Space. Up arrow, space. And then what is the anagram.cpp? That is WC is a command in the operating system that says read the file called anagram.cpp and tell me how many lines there are in that file. That's a -L for lines. If you hit enter, it'll tell you how many lines you got. 113. We get 120, right? So our program has 113 lines of code in it. Now we're going to try and compile it and see if it compiles. And obviously, there might be syntax errors and things like that, and we can try and fix them now. Okay. So it's a G++ space -O anagram. That's the output file. Anagram space anagram space anagram dot no just anagram space anagram.cpp. Anagram. You can hit tab, it'll autocomplete. Yeah. Right now, if you hit enter, it'll compile it and we'll see all the errors. If it has any errors, it'll tell us what the errors are. We can go and fix it, recompile it, and then it'll be ready to run. Hit enter. Okay, all right, good. So unused. Oh, word underscore lists. I think it's I think you used word underscore lists and not lists. Yeah, okay. All right, good. We can fix these things very easily. Go back to your code. Right, go to the top where you have the double vector declaration. All it's saying is that see, here's the thing. G++ on this computer is invoking an old version of the GNU C++ compiler, which was not able to account for the fact that in that type vector, right, two angle brackets right next to each other is not an operator, because you know that two angle brackets next to each other is actually a right shift operator. Yes. This left shift is like that and right shift is like that. So the compiler couldn't tell. The old compilers couldn't tell whether it was an operator or it was that. So we'll make it clear to the compiler by just putting angle bracket space angle bracket, and that'll be enough to silence the compiler. Okay. Where you have the vector, put a space between the two angle brackets. Okay, that's all we need to do there. And now where you have the word lists, I think it was word underscore lists, and some places you're using word lists and some places you're not using that. So fix that to word lists. And if you look at the terminal, it'll tell you what line it is, but yeah, I'm pretty sure. What line is it? Line 35, 18, 38, 18. 35, line 35. You have a word list somewhere. Yeah, there you go. Yeah, I see. All we need to do now. Yeah, you have word lists. You have. There you go. Yeah, put it, and then one more under that. And then we have 35, line 35 further down. I think we have one more. There's word lists somewhere. You don't have any word lists now? Yeah, all right. You just compile it. If there's an error, it'll tell you. Yeah, go back to the terminal. Save it. Save this. Did you save it?
Yeah.
Okay. Now up arrow and hit enter. It'll compile again. Oh, all right. Okay. Those were the only two errors. Okay. And we fixed them. Now control L, go to the top. Right now, if you hit enter, if you say /anagram, we'll be able to play this game. What time is it now? Hey, great. Okay, we're within class time and we actually managed to complete it. Hopefully no logic errors. Okay, and we may be able to play this game. Hit enter. Okay, all right. Who can do this? Okay, who can unjumble this word? Yeah, all right, go for it. All right, Now you got a 4-letter word. You got a 4-letter word. Can you unjumble this? Someone else, okay? Not who's no, not Leo. Okay, Leo was typing.
List.
Someone else has to call out.
List.
All right, okay. This is it's getting harder and harder. Isn't it?
Rifle.
Rifle. Okay, cool. Wow.
Hungry.
Hungry. Wow. Who said that, by the way?
Will.
Will. That's cool. I think that is correct. Yeah.
Willing.
Oh yeah.
Oh my gosh, you guys are like kicking ass here. You know, I'm still trying to parse the letters, and you're getting these things.
Oh,
How are you guys doing this?
that was a good one. That
Yeah,
was a
you
good one.
nailed that.
Yeah.
Who did that, by the way?
Oh, I did.
Oh,
Leo
that was
did
just
that?
Leo. Yeah.
Almost Leo.
Wow. I'm just trying to figure it out, and there's not raccoons.
You
Wow.
know, side note, actually, I don't think we ever seeded Rand.
Oh
which-
yeah.
Yeah, which isn't super important.
Good. Yeah. We'll seed Rand after. Okay, let's not kill this game. We'll finish this game, and then you can go and seed Rand later. Hey, what is this? Wow.
I genuinely can't tell.
Can someone find out what it is? Or try something incorrect. We'll see what happens. Focus. I don't know. Hit enter. We should say try 2 now. Oh, it didn't, right? It should. So there's things that we should do is that if you didn't get it, you should print a message saying, "Hey, that was wrong. Try again." And also one more thing we can do is that when you say wrong, try again. One thing you can do is rejumble the letters.
I think it's confusion.
So yeah, it'll be easier for people.
Wait, oh yeah, it is.
Confuse.
Yeah.
You're a genius.
Oh my,
Is it confused?
Yeah.
that was good.
Hey, I got it. I got confused, right? I didn't get confused, but I got this word. Try confused. Not confusion, confuse. Oh, there's no
confused.
E. There's no E. There's no
Yeah.
E.
Does he-
Okay. I'm pretty sure it starts with a C-O-M. Is it?
Efficiency.
Efficiency, yeah. So
Hmm?
efficiency.
No, there's no E. There's no E.
Oh, we're on the next word.
Oh, what happened to that? What
There's
happened to that
two
word?
E. You should pick
Yeah,
two.
try that.
How come you get confusion? So how did confusion worked?
Yes.
But there was no E. Oh, confusion. Oh, I see. There were two N's. I totally didn't get the two N's. Yeah. Oh, wow. Who got confusion, by the way?
That's me.
Bro, Andrew's computer.
Nemo, was it?
Yeah.
Good. That was pretty awesome. Okay.
Not efficiency. That
Look at the
was
screen here. Look at the power.
Efficiency. It does look like efficiency. Oh, you got efficiency too.
no. I was asking
Okay,
who
this-
got it.
So someone got it. Efficiency.
Who got efficiency, by the way?
I got efficiency.
Alec, you got efficiency?
Yeah, environment.
Hey, that's pretty cool. That's pretty cool, man. Environment. Who got environment? No, that's not environment. Oh my gosh. Hey, I hang on. Okay, are you guys looking up some resource? Are you just typing it? Are you using a resource on the internet to find out what these words are? This is incredible. This is incredible. You know, I mean, if you are sitting on a plane, you're sitting in a plane, someone's playing a game next to you, you can just, kick ass right there. You're instantly popular person on that entire plane. This one is like super duper.
Is it
hard.
like coordination or something? Oh no. No, there's no way.
Professor,
Anyway,
probably
may I
is.
may I ask a question?
How about
Mask, where
Introduction.
does it get the words from?
Oh yeah.
it gets the words from this list that he created, word lists in 3000.txt.
Oh,
Is
okay.
is this one introduction?
Which one? Which one?
Yeah, it's
Introduction.
Hey, how are you guys getting this, by the way? How did you get into introduction from that? This is incredible.
Just a
This is-
lot of
Good
people.
guess.
Are you,
I don't know.
I guess it's just a guess. Who got introduction?
I did.
Alec, you're like, that's like, so tonight, not tonight, Thursday night, when you have a dinner with your friends, Thanksgiving dinner, play this game, okay? Before that, add some bells and whistles and all. So let's go back to the code. We have a little bit of time, and then we'll just make some changes to the code. All right. So the things that we noticed in the code are when where you have round number plus plus, round number plus plus, where you have plus plus round number on up further up plus plus round number. Okay. There on I see in play around. You got to do this in play
I was gonna
around.
do it here.
Yeah, try num plus plus, and you can say you can jumble the word again. You can jumble the word again. You can say what did we use for jumbling word? Yeah, you can say jumble. Oh, we're not even using that variable called jumbled word. So you can get rid of the variable. You can get rid of the. Are we using the? No, hang on, just a sec. Let's make sure. No, we are using the jumbled word, are we? Oh, we are using
Yeah.
thank goodness. Right. So yeah. Right. So what we need to do is jumbled word equals jumbled word. Okay, so you can rejumble it, right? And jumble. Yeah, you can say jumbled word equals jumbled word equals jumble open parentheses word semicolon, and then on the next line you do a cout. That was wrong. I rejumbled the word for you. Here you go. All right. And then colon and then the word again. I rejumbled the word for you. Here you go. Colon. Yeah. And then the word. Jumbled word and then jumbled word. word, and then endl. And then let's also make it cleaner. When you get to the end of the round, just print a blank line so that every round is like set off on, at the end of the plus round number, plus round number, you do an cout endl also, right? After plus round number, you just do a cout endl. Cout endl. I think that'll look nicer in the output. Now compile it and run it. Let's see if that looks better. And then you can obviously do you can do more interesting things here. Did you save it? No, you got to save it and compile it. Compile it. Up arrow one more time. Yeah. Right now, if you hit Control L, go to the top and run it now, you will see the new behavior. Up arrow. Yeah. Enter. Okay. Oh yeah. Oh, we forgot to do the srand. Go back to the code. Put the srand, like Alec or someone mentioned. Andrew mentioned that we need to do srand. Now kill it. Control C out of this. Yeah. Now go back to the code in your main. Go to your main, and yeah, right there, beginning. Yeah, right there. Enter. And you say srand. Open parentheses. Unsigned within parentheses. Unsigned. No, within parentheses itself. You got a second pair of parentheses. Unsigned space. Open, close, space. A time. And then open parentheses. Null pointer, nullptr. And then close. And enter right there. Okay, good. I think now we'll get different words each time, right? Save it, compile it, and run it, and we'll get different words.
Yeah, we're
Oh,
missing
what's going on here?
We're missing a parenthesis.
Oh, you're missing. Yeah. Put it in. Not there, at the end. Save it and compile and run it. Yeah. Okay. No, yeah, we got no, is that done? Oh, there you go. Yeah, we are trying out the new behavior. All right. Yeah. And try again incorrectly, and we'll see if we actually get a jumbled right word. No. Don't do incorrect. Yeah. Keep doing. Oh, why is it giving you the same thing again? Okay, all right. It is giving you a different thing. Now you can say do, and we'll see if we get a. No. Oh, it might have been peak. It may have been peak. All right. Okay. REHS. Fresh. Anyway, I don't know. It's very tempting. If I look at it, it's very tempting for me to. That's why I think it's going to be a really cool game for Thanksgiving dinner. Okay, so
Is it margin?
Take your.
Is it margin?
Was it margin? Oh, it is margin. Okay.
Could it also be migraine?
What is this?
No, but migraine has 2 eyes.
And it doesn't have E. No E. No E. Migraine has an E. Right. But charge. No, is this one not charge?
Doesn't have a C.
Yeah. Yeah. Here, the cool thing with the modification we made is that if you're totally unstuck, you can type some random stuff and you'll get a rejumble.
Hearing?
What is it? What is it?
Nice.
Hearing. Wow. Okay. Yeah. Anyway, I think it's fun. We shouldn't be wasting too much time playing a game. Okay. This is all about learning to code and learning to create a game, not playing a game. But was this fun? Now raise your hand if you think this was a fun.
What she said. No.
Dude, I didn't say anything important.
No, I'm saying that you didn't hear what he said and the word was hearing, so I thought that was funny.
Oh, yeah. Hearing, but I wasn't hearing. Okay.
Professor, may I ask a
great.
question about the program
Yeah,
itself?
sure.
Can you go back to the program, please? So there was kind of a double vector line. I really didn't get that.
Which one?
Like, I think it was on top. Yeah, so vector string. So what does this stack mean again?
All right. Suppose you only had a vector of string. What does it mean? Only a vector of string.
Well, that its
It's just a
length
string of
is the
vectors, right?
number of letters. I
Yeah,
mean,
it's
the
no
number of
number of
characters.
letters. It's a number of words. A vector of strings. A vector of strings. Right? Many strings.
Oh, many strings.
Yeah, that's one vector. So if you have vector string, that's a vector of strings. Many words in that one vector. Yes or no?
Yeah.
Now, suppose I have many of those vectors. Suppose I have 15 of those vectors. I can put them all in another vector, right? A vector of strings.
Yeah. So it's one vector. So it's basically a vector with a couple words in that, right?
No, it's a vector with it's a vector with 10 vectors inside of it. It's a vector of 10 vectors.
Oh, I see. And each vector is a couple words.
No, not a couple of words. Each vector is all the words of that length.
So the vector string, is that a single word or a couple words?
A vector of string is a list of lots of words. So if you say,
okay.
if you take, yeah, a vector of, so if you take the 3-letter words, maybe there's 15 3-letter words. Yeah.
Mhm.
Then, so you have word lists of 3 equals that vector. It's an entire vector. Word list of 4 is another vector, an entire vector. You have vectors and vectors and vectors. You have many vectors. A vector of those vectors is what we're using there.
Right. So it's just a way to group them, basically, right?
Yes, exactly. We're just using,
Okay, I see.
instead of giving each vector a different name, we're just putting them all in a
Mhm.
collection.
Yeah. Okay. Thank you. That makes sense.
Great. Now, raise your hand if you guys felt you got some new learning out of what we did today, new concepts and new interesting things that we found. Yeah. Great. Was this fun and interesting?
Professor, I have a follow-up question to that. So how does the code knows to sort them based on word length?
I'm sorry, how does what know?
How does the code know how to sort the vectors based on word length?
No, it's not sorting the vectors based on word length. If you look at it, all we're doing is that we're getting a bunch of words. If you look at that word list 3000.txt file that Leo had, you'll see that words are not in a particular order, right? I mean, the first word is short, the next word is long, and then the word after that, it's not ordered by increasing length or anything, right? That list of words is random. So all we're doing is getting one word at a time, and then we're stuffing it into the correct vector, right? Because we have 10 vectors here. The first vector can only have one letter words. Second vector can only have 2-letter words, and so on. So when we get a 3-letter word, we stuff it in the 3-letter word vector. When we get a 5-letter word, we stuff it in the 5-letter word vector. Yes.
So it does that automatically?
Yeah, if you look in the code, can someone share the code, or if we look at the code, we'll be able to see it. We get the word, and then we get the length of the word, and the length determines which vector it goes into. If the length of the word is 5, it goes into vector number 5. If the length of the word is 3, it goes into vector number 3. If you look in the code, that's what you'll see. Yes or no?
All right, I'll check it out later.
Yeah. Well, if Leo's gone, but hey Leo, oh boy, we lost the code. I hope he shares the code, or someone should get in touch with him and ask him to share the code so that all of you can have it on your laptops and you can take it to dinner on Thanksgiving Day and play this game. I think it's fun, right? Because even if people say I'm not in a game for a computer game, I'm not in the mood for a computer game, you see how when you start this game, everybody is automatically engaged. So you give them a bunch of jumbled letters. I don't think there's any human on earth. They'll say, oh, they can't say, oh, I'm not going to unjumble it. Okay. Somehow they're going to be unjumbling that in their minds. So it's a very catchy and interesting game. I think it'll be fun. So hopefully, by the way, raise your hand if you want a class on Thursday morning. We'll just do another project just like this. Okay. If you want a class on Thursday morning, I'm happy to give you a class, because at the end of the day, Thanksgiving is only at the end of the day, right? Thanksgiving is, you only have the dinner with the people you want. Okay. So you're not going to have, if you want a class, I'm happy to give a class on Thanksgiving Day. Otherwise, that's fine. We'll meet on Tuesday. But on Tuesday, hopefully, some of you can share your experience of, hey, I took that game and I had that with my Thanksgiving buddies, okay? And my family, extended family, we played this game and we had a great time. Or we didn't have a great time. Or maybe we had some other ideas bubbled up, right? My sister said, maybe this will be nice to put into the game, right? More features and those things. So you come back with some feedback on Tuesday and we'll see if this was actually cool. I think this actually worked out really nicely. I'm very pleased I came up with that idea on Friday, which means we can actually do that for next quarter, a couple more quarters, I think, before it gets boring. So that's very nice. Thanks to you guys, especially Leo, who's not here anymore, very patient. And also he seems to have some experience because he was typing ahead, but hopefully that didn't throw some of you off. And if any of you felt left out and did not understand anything, please do speak up, okay? Either here or in the forums, or make a post saying I didn't understand what we did in this code. Can someone explain, right? And there's so many of us, we will absolutely help you, right? Walter, me, some of your classmates. Leo already obviously knows what's going on, so we can all help you. Right? Thank you all so much. Have a great holiday. And if you want to come back on Thursday, let me know one day before and I can do a class on Thursday morning. All right, we'll do another fun project like this. We'll pick up an idea, or you can come with an idea and say, hey, I'm not doing anything on Thursday morning. Can you help us code with this idea that my friends and I came up with? Right, we'll do it. And I think it'll be fun. Right, I had a great time today in class. So thank you all for giving me that experience. All right, I'll see you guys later.
Final question.
Bye.
Final
Yeah, sure.
question.
Susilo.
What is the flair for these kind of codes in the forum?
Oh, I think you can just say a foothill. Just say foothill.
Okay, thank you.
There's a foothill flare.
Okay.
Have a nice Thanksgiving.
Professor, may I ask you something?
Yeah, sure.
So I'm a bit behind right now on the question because of although UC application and other course load, but I think I can catch up in time. So if I understand correctly, if it freezes, then I just need to complete all of them in order to unfreeze the other ones, right?
Yes. If anything is frozen, but by the way, I mentioned this to my 2C students. These freeze states are only there to catch slackers who are basically just goofing off and then just come by suddenly and copy solutions. Right, I can see you guys. You're all questing hard and working hard and trying to attending class, learning things. So for you guys, you can assume that freeze days don't apply, hard and fast.
Okay, thank you. It just for me, it's easier to work like in burst more, which I know you don't like as much, but it just because I love to like just tackle like if I'm doing like this homework, I just like to do as much as I can.
No, that is okay. That's not burst mode. That's not burst mode. Burst mode is very different from that. Okay, burst mode is just blindly submitting lots and lots of code and not working and then disappearing and then coming back and trying these things. They're grinding and by I can see these logs. Okay, I can see these logs, and the only thing I look for is whether you guys are working hard and having fun. Okay, those are the only two things that matter to me. I don't care about anything else.
Okay, thank you. I appreciate the clarification.
No worries. All right,
Thank
see you later. Have a great holiday.
You too. Bye.
Bye.